Dear students, the question number 26 is based on the concept of RC circuit. The question says that the time constant for charging of capacitor C when switch S is closed as shown in the figure is. Dear students, we know that the time constant of any RC circuit can be written to be equal to the net resistance multiplied by the capacitance. If we draw the diagram of the circuit again, including the internal resistance of the cell in the circuit, we can get a crystal clear picture of the problem. So dear students, this is the effective simplified circuit diagram of this circuit. Now we can see that this 4R resistance and this 4R resistance, they both are in parallel. Therefore the effective resistance of these two resistances combined should be equal to 4R by 2, that is equal to 2R. Now dear students, since this 2R resistance, this 2R resistance and this 4R resistance are all in series, the net resistance can be written to be equal to summation of all these resistances, that is 2R plus 2R plus 4R, that is equal to 8R. Therefore dear students, we can write the time constant to be equal to 8R, that is the effective resistance multiplied by the capacitance C. So the correct answer therefore for this particular question should be option number 3. Now dear students, let us proceed to the next question, that is question number 27. Dear students, question number 27 involves a circuit of capacitors, and it says that the equivalent capacitance of the circuit as shown in the figure between points A and B is. Now dear students, a circuit of the capacitors has been given to us, which can be further simplified into the following circuit. Terminal A as per the question, terminal B as per the question. From terminal A, a capacitor equal to 2 microfarad, which is this capacitor. From terminal A again, a capacitor equivalent to 6 microfarad, which is equal to this capacitor. Further as we go, a capacitor of magnitude 8 microfarad, that is this capacitor. As we go further, a capacitance of 8 microfarad, that is this capacitor. And as we move further, a capacitance of 24 microfarad, which is this capacitor. Now a capacitor of 8 by 5 microfarad is also in the circuit, which we can represent here. Now dear students, we can see that this particular part of the circuit is equivalent to a balanced Wheatstone bridge, because in the left part 2 by 6 is equal to 1 by 3, wherein in the right part 8 by 24 is also equal to 1 by 3. So therefore the capacitor in between, that is the 8 microfarad, which is the bridge in the Wheatstone bridge, can be removed or neglected. So let us erase this particular capacitor. So dear students, this is the final circuit diagram. We can easily see that 2 microfarad and 8 microfarad are in series, and since 2 and 8 are in series, the equivalent capacitance of these two capacitors can be written to be equal to 2 into 8 divided by 2 plus 8, that is equal to 8 by 5 microfarad. Now dear students, again 6 microfarad and 24 microfarad are in series, so we can write the equivalent capacitance of these two capacitors to be equal to 24 into 6 divided by 24 plus 6, which is equal to 24 by 5. Now dear students, this 8 by 5 microfarad capacitor, this 24 by 5 microfarad capacitor, and this 8 by 5 microfarad capacitors, all these three capacitors are in parallel. So the effective capacitance can be written to be equal to summation of all these capacitances, that is 8 by 5 plus 8 by 5 plus 24 by 5, which is equal to 8 microfarad. So the correct answer for this particular question should be option number 2. Now dear students, let us proceed to the next question, which is question number 28. Dear students, the question number 28 says that the correct statement among the following is: Statement 1, all free charge particles move from a region of lower electric potential to region of higher electric potential. Option number 2, the electrostatic field inside a conductor is 0. Statement number 3, the surface of any conductor has uniform charge density in electrostatic condition. Or option number 4, which says that both 1 and 3 are true. Now dear students, let us analyze each statement individually. Considering statement 1, dear students, we know that positively charged particles move from a region of high potential to a region of low potential, whereas negatively charged particles move from a region of low potential to a region of high potential. Therefore, the statement number 1 is false or incorrect. Now considering statement number 2. Dear students, it is a property of conductors in electrostatics condition that the electrostatic field in the conductor is equal to 0. Therefore, statement number 2 by the virtue of property of conductors is true. Now considering statement number 3. The statement number 3 says that the surface of any conductor has uniform charge density in electrostatic condition. Now dear students, the charge density and its nature, that is whether it is uniform or uniform on the surface of the conductor, depends on whether the radius of the curvature of the conductor is uniform or non-uniform. For example, if there is a conductor of arbitrary non-spherical shape, then in that case the surface charge density on the surface of the conductor would be non-uniform. Therefore, or the statement number 3 is also false. So among all these three statements, only statement true is true, and therefore the correct answer for this particular question should be option number 2. Now dear students, let us proceed to the next question, which is question number 29. Dear students, question number 29 involves a circuit of resistors and says that the equivalent resistance across points A and B in the circuit as shown in the figure is. Now dear students, in this circuit we can see that these two resistances of resistance 2R each are in parallel, because the potential across both the ends or the terminals of the resistances is same, because they are connected to the same conducting wire. So the equivalent resistance of these two resistances should be equal to 2R by 2, that is equal to R. Similarly, these two resistances of resistance 2R each are again in parallel, and on the same principle the equivalent resistance of these two resistances should be equal to 2R by 2, that is equal to R. Now dear students, these 4R and 4R resistances are again in parallel, and the equivalent resistance would be equal to 4R by 2, that is equal to 2R. Dear students, we can now proceed to make a simplified circuit diagram for this particular question. The simplified circuit diagram would look somewhat like this. Now dear students, we can see that this R resistance and this R resistance, these both are in series, whereas this 2R resistance is in parallel to this whole arm of both of these resistances of resistance R combined. The equivalent resistance of these two resistances combined is equal to 2R, and since this 2R is in parallel with this resistance 2R, the equivalent resistance of the whole circuit should be equal to 2R divided by 2, that is equal to R. Therefore, dear students, the correct answer for this particular question should be option number 4. Now, let us proceed to the next question, that is question number 30. Dear students, question number 30 says that two bulbs B1 and B2 with ratings 10 watt 220 volts and 20 watt 220 volts respectively are connected in parallel across a 440 volt input supply. Then option number 1, both bulbs will fuse. Option 2, only bulb B1 will fuse. Option 3, only bulb B2 will fuse. Or option number 4, no bulb will fuse. So dear students, in the question it has been given to us that there are two bulbs, that is bulb B1 and bulb B2. Both of these bulbs are connected in parallel, and the input voltage across which these bulbs are connected is equal to 440 volts. Now dear students, as per the question, since the individual ratings of both the bulbs is equal and is equal to 220 volts, and since the input voltage is 440 volts, and because both the bulbs are connected in parallel, both bulbs will attain a voltage of 440 volts. Now 440 volts is greater than their rated voltages, therefore both these bulbs will fuse together. The correct answer for this particular question should be therefore option number 1. Now dear students, let us proceed to the next question, which is question number 31.